So, what is debugging? If you have been into coding at some point in time, debugging comes naturally to you. But most functional consultants do not come from a coding background. So, how do we understand debugging? Let me take an example of golf, and then through that example, I'm going to introduce debugging to you. When I was trying to learn golf, I really had a lot of trouble doing that swing. For example, what do? I take the club to a certain angle and then start a swing, right? So this is what we do in golf. And when we are doing that, we start with some goals in mind, right? What do we want? We want the ball to go a certain distance. And in order to do that, the swing needs to be done with a certain speed, a certain angle, a certain way in which it should contact the ball, and so many different parameters. And a computer program is not much different, right? If you take a program, say a cost center report, I'm taking this report because it's available in any standard IDS system. It's a Z program, custom program. So what does any typical report have? It has input parameters, where you tell the system what are the parameters based on which you want the system to perform a search or execute an operation. It could be cost center dates, cost center number, employee number, so on and so forth. And then we have output. And output is typically a grid of data. And what happens in between is that SAP executes a program. A program quite similar to how my mind runs the program of doing that golf swing. Now, if I can hit the ball exactly the way I want, everybody can be Tiger Woods. But of course I'm not. So I have a problem with my golf swing. So I start here, right? And go here, end the swing, and I want to do, say, 100 yards in a certain direction. I try it 10 times, 20 times, but I'm not able to do it accurately. Or I'm missing consistency. I'm not able to do it every time. So there's something wrong with my swing. I'm just taking 100 yards as an example. It could be any distance, any direction. So after trying these swings for like a week or two, I really got tired. And then one of the coaches recommended that I go to a program. So I went there, and what they've done is they put a high-speed camera, and then the camera recorded me doing a bunch of swings. That's it. And then later they put it on a computer, and then they were able to analyze my swing. So you start here, and then on the first millisecond I'm here, the second millisecond I'm here, blah blah blah, and I wanted to hit 100 yards, and the speed over here should have been 80 miles per hour, say. And in order to have that, I needed to have a speed of 50 miles per hour here. But do I have it? Well, they froze the frame here, right here. They were able to analyze that my speed was not 50, but it was 35 or 40. So I was not doing the right speeds, was one of the interpretation that they got. How did they do that? When the entire swing was on the high-speed camera, they could freeze it at any point in time and then analyze parameters. So at this point in time, they did two things. They did freeze or pause the frame, and then they inspect for values. And he was able to analyze that, my speed should have been so much, my direction should have been so much, The point being, he was able to freeze or pause the entire swing and then inspect for values at any given point in time during that swing. This was debugging. There's a problem with my swing, and he was able to find out where the problem is. So in the same way, if you execute this transaction, ZCOST, which is a cost center report, hit execute, and then these are the input parameters. And when you execute it, it's going to produce some output parameters. And behind the scenes, like I said, there is a program that executes a bunch of logic and produces a result. What logic is being executed? So go to System, Status, and this is the program that's being executed by SAP to get that desired results. Now I'm doing a Control C, copying the name of the program, and I'm going to show you how the program looks like. So if we go back and go to transaction SE38, hit enter, Control V, I pasted the program here, and click on display, and this is the program that SAP is executing behind the scenes to get me the results of the cost center report. Now, just like my coach has frozen the frame at a certain point in time, I could do that too. I could place my cursor wherever I want. Think of it like a particular angle of the swing or whatever, and then hit on this button, breakpoint. So it's put a breakpoint here. Now let me open another window and try to execute the same transaction again. ZCOST, Zcost, enter, and execute. So SAP is connecting to the debugger, and then I've asked it to freeze or pause the program at a particular point, and it has done that. Now you can inspect for certain values in variables. Well, we are going to see that in some of the later videos, but you get the general idea. So what is debugging? So debugging is the process of freezing or pausing the execution of a program to do what? To inspect for values. You want to inspect for speed, you want to inspect for angle. In this case, you want to inspect whether it's looking at the right tables and whether it's looking at the right dates, whether it's looking at the right cost centers, whether it's looking at the right employees. So these are some of the values that you might want to inspect if this program is not running right. And you proceed step by step or frame by frame to analyze how the code is flowing. And all of this to do what? You do all of this to find out if the program is working according to the expectations or not. If the program is working fine, you would not have to do debugging. But if there is something wrong with the program, that's when you would want to analyze and freeze and do all these things. And this process is called debugging. This is the definition of debugging. Now, I was able to freeze the program, all right, but I don't understand the language. I don't understand what include this means. I don't understand these tables. But what good is the process if we do not understand the underlying program? Well, we don't need to learn the entire language, but in the next set of chapters, we'll see some of the use cases where we, as functional consultants, are going to find this debugging extremely useful. So see you in the next chapter. So we are going to understand debugging standard SAP programs versus custom windows of code. I'm going to explain what it is. But before I do that, let me create a sales order, issue an output, and show you a problem. I'm going to create a sales order. Go to logistics, sales and distribution, sales, order, sales order. Now I am talking to you from an SD consultant's perspective, but you could think of any transaction. In FI, you could be posting a GL account. In MM, you could be posting a GRIR. or creating a purchase order. Now I'm going to use an order type OR, sales org 1000, hit enter, enter a customer of 1000, and I enter a material of M01, quantity of 1. Now I save this transaction, and if I go back into change or display mode, I should be able to issue an output like so. So select BA00 and click on print preview. All right, that's the print preview. Now let me do something different. Instead of choosing a standard customer 1000, I'm going to create a new customer. So it does not matter what the process is to create a new customer. I'm just going to create a new customer and use that customer instead of the standard 1000 customer to create our sales order. I'm choosing some random number, say 6790. All right, so let's use that customer to create a sales order. Same order type, same org data. So instead of 1000, I'm going to choose 6790. And the same material, and hit save. Now you see a message here saying something is incomplete. That's fine. Save it for now. So the order number here is 12072. Now let's go and issue an output. Go to change mode or display mode and then try to issue the output. No output has been selected for printing. So that means the SAP is not able to determine the correct output. Why is it the case? Let's say this is a small issue that we want to solve now. We have created a sales order with a customer of 1000. Things were working fine. But we have created another order with a different customer, 6790, and I was not able to issue an output. Why? Well, there were two cases, right? Case number one, I created a sales order using customer 1000, material M01, and I was able to issue an output. Case number two, same thing, create a sales order, customer 6790, same material, and I was not able to issue an output. Why is it the case? So let's see. Let's open the sales order, the order that we have trouble issuing the output, and go to extras, output, header, edit, and you see that no output was being determined. So SAP could not determine the right output. Now we want to debug this, right? We have checked all the configuration, things look fine, and still we're not able to figure this out. Now we can open the code behind the sales order, freeze it, and try to debug it. But it's a nightmare. Let me show you why. So if you go back and look at system, status, and the program is SAP MV45A, copy it and go open that code. The only person who can understand this code is probably the person in SAP who has written it. So what good is it if I put a breakpoint here? So this is where your knowledge of the SAP system as a functional consultant comes in. So I'm an SD consultant. I know how outputs are issued. So I have an order type, OR, and each order type is associated with an output determination procedure. And each output determination procedure contains a number of outputs. And each output is linked to a program. And if you put a breakpoint in this program, then there is a high chance that you might hit that little program section when you execute an output. So the point being, instead of starting all the way here and then going through the entire process to find out what's wrong, we are trying to narrow down the execution of the logic so that there is a better chance that we might find out where things are wrong easily, instead of going through all the way from the beginning to the end, which could be thousands and hundreds of thousands of lines of code. So let's do something. Let's go to the output type and to the output program, put a breakpoint there and see how it works out. All right. So how do we go about figuring out what's the output type? Now this is all SD specific, so don't worry if you don't understand this. The point being, I'm using the knowledge of the system as a functional consultant to narrow down the scope of the search. So go to SPRO, IMG, sales and distribution, basic functions, output control, output determination, output determination using condition technique, and maintain output for sales documents. And we know the output type is BA00. That's what we are expecting. So go select BA00 and just click on processing routines, and you'll see that for print output the program is RVA blah blah blah. Copy that and go to SE38/N SE38, which is what we use to open a program. Click display and put a breakpoint somewhere. It could be just the first line. Now that we have put a breakpoint over there, we can try and execute the program again. Go to VA02, enter the last created sales order, and that is 12073. Hit enter. Go to extras, output, header, and edit. Do you see an output here? No. Still you don't see an output. That means that routine where we have put a breakpoint is not hit. Why is that? In order to understand this, we have to first understand program flow. And that is the subject for our next chapter. You see, the flow of a program happens sequentially, step by step. So if you open the sales order program, it will contain multiple blocks. These are blocks or blocks of code. Each block could again contain one or more blocks of code. Let me show this to you. If you go open the sales order program, these are the blocks that I was talking about. So include MV45 AOZZ. That's a block of code. You can double click it and the system will open that little block of code. And that could in turn contain different blocks. So this is a block of code. This could in turn contain more blocks. So, and each block of code, for example, if we are talking about this block of code, each block of code could contain one or more statements. So these are all statements. So what is a statement? A statement could contain logic like if logic. If something, then do something. If the customer is so and so, then do this. If the material is M01, do this. If the material group is something else, do this. So on and so forth. And then there could be logic to fetch data. Okay, when you enter a material M01, fetch the data for M01. When you enter a customer 6790, fetch the data for that customer, like name, address, and put it in the sales order, right? And then you have comparison logic, less than, greater than, equal to this. So if the sold to is equal to this, or sold to customers group is equal to this, then do this logic. So you got different kinds of statements that each do a certain set of logic. And now when you look at these blocks, they go in sequence, the sequence in which they are written. Meaning, if this is the first block of code and this is the second block of code, the first block of code is executed first, and then the second block of code. And inside the second block of code, they go in this order. So this will be executed first, and this will be executed next, and then this, because that's the way in which they have been written. When you put a breakpoint somewhere over here, let's say we have put a breakpoint here. So this is the output routine, say. So when I mean output routine, this is the one I was talking about. We have put a breakpoint here, right? And when I try to execute that sales order again and try to issue an output, the output was not issued. That means even though you have put a breakpoint here, the system did not come up to this point to be able to execute that code. That means somewhere before this routine is being triggered, the program's execution has stopped. But where did it stop? Again, even an ABAP consultant cannot help you with this because it's like tons and tons of code over here. Now what do we do? Again, your knowledge of the system as a function consultant is going to help you here. Now we know that every output is associated with a routine. What does this routine do? This routine will check for certain requirements, and the requirements are okay. It will let SAP run the output control program, and if not, it will stop it right there. So let's open this routine that's associated with the output type BA00 and see if we can put a breakpoint there and stop the execution of the program. Now, how do we do that? Again, you have to go to SPRO, the same path that we have gone through previously. Sales and distribution, basic functions, output control. So if we go to an output determination procedure for orders, click on control data, and for BA00, the routine that's associated with it is 2. So what does 2 do here? Click on the drop down, select 2, and click on the source code. Okay, so this is a program that's being executed to determine if an output should be triggered or not. Okay, now you can put a breakpoint here somewhere. Let's say put a breakpoint here and try to execute the sales order program again. So go to VA02, enter, go to extras, output, header, edit. And there you go, your debugger has started. That means that we have hit that point where we think that SAP is going to stop. Now what is being done here? Now this is called the debugger. We have seen this in the previous chapter a little bit, but we're going to explore a little bit more here. This is where we have put a breakpoint and the system has stopped there. Again, I don't understand this code either, but we're going to go through this step by step. This is a form Kobe 002. A form is basically a chunk of program which has got basically 10, 20, 30, 100 lines. It's a small section of the code. And it has these statements, like I said. 1 statement, 2 statement, 3 statement, 4 statement, 5 statement. Statements. Each line basically is a statement. And there are different kinds of statements. There is an if statement. And then there are comparators, which says this is equal to 4, that is equal to 2. So many different kinds of statements here. Now we can go through these statements step by step. Now remember the golf program? My entire swing was frozen, put on video, and then they could pause my swing at any point in time and then go through step by step, meaning millisecond by millisecond. Same thing here. Currently, the code is frozen here. Now, if you want to move to the next step, which is this, you could do something like this, which is you have to hit this button, execute, F6. And then this arrow over here, which points out to the place where we are currently frozen or paused, and then move to the next step. You watch this arrow, and when I hit this button, it will go to the next line from 34 on to 35. Here, there's an if statement that's evaluating something and then doing something else. And then it says com kbv1-uv all. Again, I don't know what that is. Okay, we're going to find out about this in the next chapter. So it says if something not equal to C, then exit. Right? So let's see if that is equal to C or not equal to C. It's just a plain comparison. So again, click on this button and then it goes into the loop. That means it is not equal to C, and go to the next step and it says exit. That means we are done here. This output routine is no longer going to execute. And how do you know that? You see, this is the program, right? 002, that's the routine. Now if I hit execute again, it's still in the program 002, execute again, and then it's got out of that program. So what has happened here? So BA00 is associated with the routine 002, and if this routine is passed, meaning if it is successful, then it calls the output program. But if it fails, it does something else. We don't care what it does. Because of certain condition, this has failed and it exited the program, and it's gone over to do something else. Now at this point, you have two options. Option one, ask your ABAP consultant to come help you understand that program, because you don't understand coding. So ABAP consultant is the first option. The second option is you could try and go one step further and understand what kind of business logic has failed. Go further to see where the logic failed. If you have gone this far, I think you have done a pretty good job of debugging. It's okay. It's not bad. But this is a very simple example. Not all examples are this easy. We were able to quickly narrow it down to a particular piece of code because we know the logic of how SAP works behind the scenes in terms of outputs. Sometimes that is not the case. There are multiple windows of code where things could go wrong. And the different windows of code could be routines, user exits, bodies, BTEs, business transaction events. These are some of the standard SAP windows of code where you could have written some code to affect your functionality. The example that we have seen is a routine, an output requirement routine. Similarly, there could be user exits that could affect the way your program works. There could be bodies or there could be BTEs. Sometimes you might not be able to narrow it down exactly to the point where your code is failing. if there is more than one window of code where things could fail, then it's not easy for an ABAP consultant to debug all the different windows of code. So in cases like this, it would be better if, as a function consultant, we understand debugging a little bit, at least go through a little pieces of code and be able to quickly identify certain things that are really easy. Now, we are not trying to learn ABAP coding here, but we are just trying to see what's the low hanging fruit, try to hit it, and make our life easy. Now, in order to do that, we have to understand some basics of ABAP. Now, I'm not going to teach you ABAP here, thank God, but we're going to learn certain things like structures, internal tables, loops, if statements. Probably that's about it. So in the next set of chapters, we'll deal with a bunch of technical stuff. So these details are really necessary if you want to see and understand some business examples. So let's summarize what we have learned here. We have learned code flow, which is the way SAP goes through code and executes them block by block, line by line. We have seen what standard code is, which are programs written by SAP and delivered as part of the ERP package. And we have seen that debugging them is not something a function consultant should ever attempt to do. And we have also seen windows of code, which are specific pockets that SAP provides for us to be able to customize the way SAP works. And we have seen examples of these, like VOFM routines, user exits, bodies, business add-ins, or BTEs, business transaction events. Most of the time, as a function consultant, if you are debugging something, you'll be in one of these windows of code. All right, see you in the next chapter. In this chapter, we are going to talk about structures. What is a structure? A structure is a grid of data that is populated by SAP at runtime. No, it's not a table, but looks like one. Let's take the same example and analyze the structure. So we put a breakpoint in our routine, and I'm going to create a sales order. Using the same customer that we have known. And as soon as I try to save it, it should trigger the debugger. Why? Because we have put a breakpoint here. Let's see what this really means. So go ahead, put your mouse over there and double click it. Just double click on com kb v1 uva all, and it's shown here. What is the current value of it? A. The current value of it is A. And this over here, com kbv1, is an example of a structure. And uva all is a column in that structure. If you want to see the entire structure, what you can do is just delete this field, the column, and click enter. And you see that it's a structure. You can double click on this, and then it will show you all the values or columns in that structure. And there you go. So this is the structure, comkb1, and the columns or fields in that structure are these: VBELN, VKorg, VTWeg, doesn't matter what they are, but these are all the different columns in that structure. So if you go down below, you should be able to see the UVA all. There you go. UVA all, and the value of it is A. Just before we go further, let me show you how to see the structure COMK-BV1 and the different fields in it, what they really mean and all that stuff. Go open another screen, go to SE11, and in the database table field, just put in the structure and click on display. And it tells you that it's not a table but a structure. And what's the difference between a table and a structure? A table contains data all the time, but a structure contains data only at runtime. What do I mean by runtime? Runtime means when the program is being executed. When a program is being executed, the structure is filled with data. It's like a temporary storage place. And once the program finishes execution, for example, sales order is saved, closed, then there is no longer any data in the structure. So once again, a structure is a temporary storage place in a program where the values are stored at runtime. When I mean runtime, it's during the execution of the program. And when the program finishes execution, there's no longer any data in that structure. So if you go to SE16 and try to view data in a structure, you won't have any values because there is no data there. It's just a temporary place during the program execution when data is filled up, and after that it's gone. Whereas if you go open a table in SE16, you would definitely have some data if it has data. All right. So our structure here is COMK-BV1, and the value that that program is checking is UV all, right? So go to find and click on UV all. So this is the field that we are looking at, UV all. And what does it mean? It means general incompletion status of the header. Now we are on to something, isn't it? So we said COMK-BV1 is a structure. And we said a structure is a grid of data which contains fields, field 1, field 2, field 3, field 4. And one of the fields is UV all. And the value of it at runtime, when the program sales order is being executed, the value of it was A. I put a single quote here to signify that it's a single character or a string. But the value that it is checking over there is not equal to C, meaning if that value, whatever that value is, UV all, is not equal to C, then exit. That means if it is not equal to C, exit the program. In other words, it should be C for the output to be issued, but the current value is A. Now again, your ABAP consultant will not be able to help you with this. This is where your knowledge as a functional consultant comes in. So what is this field UV all? We know it's general incompletion status. And as a functional consultant, I should understand what incompletion status means. As an SD consultant, I know that there is something called as a completion status at the header and at the line item level. And this one talks about the status at the header level. What are the different values? Just go double click UV all and double click the domain stat v. Click on value ranges. And you'll see that A means not yet processed and C means completely processed. Let's go back to this statement. What this field means is the completion status of the header. So if it is fully processed, C, then proceed. If it is not equal to fully processed, meaning it's partially processed or not yet processed, A or B or blank, then exit, right? It's making sense now? The logic in that program just says that if the header of the sales order is not fully processed from an incompletion perspective, exit the program. Let's go back and stop the debugging by clicking on this button. Do you really want to exit? Yes. And go back to create the sales order again. And let's see where we have went wrong. Save it. It's going to start the debugger, but that's okay. We don't care. Execute it. Execute it. And it says document is incomplete. In the previous videos, we have seen this case, but we have just chose to ignore it and click on save. But this time, we'll see where the document is incomplete. What is incomplete? Incoterms, payment terms, da da da. So let's go back and fill that piece of data. So go to header, Incoterms. Just put in some Incoterms. That's okay. Now check if the document is complete. Click on edit, incompletion log. The document is complete. Now save it. And it hits the breakpoint again. And now let's see what the values are. So we're going to go step by step. Okay, execute F6. It went in. Now just double click this. And the value of that is C. That means that we have completed the document. Now if the document is complete, the value over here is C. So this test over here should pass. Let's see. All right, see, it skipped this all the way and went to the next if statement. So this test of if and end if, this block of code was skipped because the value is now equal to C. And then it goes on to do a bunch of other tests, which we don't care at this point. Let's say we hit execute, 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 and the order has been saved. Go to view or change the sales order, enter your order number, go to sales order, click issue output. There you go. We got our output. Yay. So what did we learn here? We learned what are structures. We know how to view the data in structures. And this is at runtime. We know the difference between the data that's populated in a structure versus the data that's populated in a table. So a structure is always runtime versus a table which has got static data all the time. And we know that in SC16, the data browser, you can see the data in a table but not in a structure. And we know how to view the definition of a structure. Go to SC11, enter the structure name, and you can see the fields in that structure. Messages are probably the most important clues to debugging for functional consultants. Let's see an example. So if we take our cost center report, Z cost, and then execute the program, the system gives you some results. Say, for example, the results that you see here are not what are being expected. Say the user complains that something is wrong with the data, and you want to find out where exactly things went wrong. Wait a minute. Programs can go wrong? Yeah, programs can go damn wrong. After all, it's a human that writes the program, isn't it? And that's one of the reasons why we are learning debugging here. Programs can go wrong, and we as functional consultants can do our own part in debugging. So you want to find out if the program is doing the right thing or not. So how do you know? So a program typically does two things. Step number one, get the selection data. In the case of our report, this is our selection data. Company code, selection period, cost center, so on and so forth. Go to the correct tables, the database tables, fetch data, process data, and finally display output. Typically, in most reports, this is how the program runs at a very high level. So as a functional consultant, what can you do? Well, we know what the selection criteria is. Nothing that we can do there. Go to the tables so we can check whether the report is going to the right tables. So this is one area that we can go cross-verify. And then we can find out if it is fetching the right data. It's not just enough that it goes to the correct tables. It should go and fetch the right data. We can cross-check that. And then after that, it processes the data and displays output. Well, there is some bit of debugging that you can do here, but I would leave this part to the ABAP consultants because there is so much of logic that can go on inside. You really don't want to go there. Just leave that part to the ABAP consultant. But these are two areas that you as functional consultant would understand very well and can help with debugging. Now, coming back to our messages, what is the role of a message here? Now, as a function consultant, we typically tend to view a report or a program like this. There is an input and there is an output. Program runs, takes the input and creates an output. So as a functional consultant, input and output are the only things that you know. You don't know what's happening behind the scenes, but you know the logic. You know the logic that should have run when this program executes. You just don't know how it's being done, meaning the code. And the intention is to not understand the entire program either. We don't want to do that. If we do it, we become ABAP consultants. However, when you see a message, for example, if you're expecting some data, I just entered some dummy company code and I see this message. No data selected. When you see a message, it's a way in which the program is communicating to you saying something is right or something is wrong or this is what has happened. In this case, it just says, I can't seem to find any data for the options you have selected. Well, in this case, I'm okay because I've just selected a dummy company code 9999. Obviously, there's no data. But for some reason, if you think that you have entered everything right, say the company code right, period right, cost center right, and executed, and still SAP shows you that message, then something is wrong. You have to go debug the program. And I'm saying messages are good clues for you as a function consultant to dive into the program precisely to the point where you want to see something. So the code behind the scenes is like a big machine. You don't want to see how the entire machine works, but you just want to go to the exact point where you think the things are breaking, and then maybe check for certain things and then quickly go back. So a message gives you a starting point to search for what went wrong. For example, what's the program that's running this cost center report? Go to System, Status, copy this, open another window, go to SE38 and paste this program and click Display. What it does is it opens the source code for this program. So this source code over here, hundreds or however many number of lines of code, is the big machine that I was talking about. I don't want to go line by line, step by step, gear by gear until I see a point where things might have broken. Instead, the messages that we see on the screen are quick clues or starting points for us to dive into the program precisely to the point where things are breaking or we think are breaking. In this case, we are going to jump right to the point where this message is being issued, with the hope that we're going to find out something over there that might have gone wrong that results in this message. So how do you do that? How do you dive in? Well, we know the error message here. So step number one is click on Help. We want to find out what is the message class behind this little display. Because sometimes it's a message, sometimes it's a pop-up, sometimes it's an error. Irrespective, the goal is to find out the message class and the message number, which uniquely identifies a message. We'll see what it is. So click on Help, and this is the message number, RP016. Most messages will have this kind of a format, 2 plus 3. The first 2 characters is the message class, and the last 3 characters or numbers is a number, message number. So make a mental note of it, and then we're going to go open that message class, RP016. Hit OK. Step number 2 is to go to SE91, which is a transaction to view a message class, and then type in RP. That's a message class, and the message number is 016, and click Display. This is the message class and number that was used to throw that message that we saw when we ran the cost center report. Now, step number 3 is to use this button. This button is called the Where Used button. It's a pretty useful button for function consultants when you want to find out and dig through where things are. Let me show you how. If you click on that button and say just programs, nothing else, click OK. SAP shows you a list of 111 lines of programs, different programs. In fact, 111 such programs where this message is being thrown. But why do we care about all these programs? We only care about one program, the cost center program. This message could be used in n number of places. We don't care. We want to debug our cost center report. So go to search and then enter the name of our program. Go to System, Status, and there we see our program. So enter the name of the program and click OK. So this is our program, and if you double click it, you'll see all the places in the program where the message is being thrown. Simple enough, right? So double click the first line, and it takes you right to the line where that message is being thrown. So go put a breakpoint there. Go back and double click on the second line. Again, you go exactly to the line where that message is being thrown and put a breakpoint there. Go back. We are done with this screen. So what we have done essentially is to take that message class, go to its definition and click on where used. When you did that, SAP gave you a list of programs where this message is being thrown. And from that, we have filtered out all the other results and focused on the program that we want to debug. And then SAP has shown us precisely the lines where the message is being thrown. It could be one or n different places. Put a breakpoint in all of them. Come back. Now execute the program, zcast. You see SAP has stopped the program right where you put a breakpoint. Now, we have taken a nosedive into the code, right into the point where the message is being thrown. What do we do now? Now, what we do at this point is something we are going to discuss in the next chapter. But for now, what I want you guys to understand is messages or clues or starting points for you to debug large chunks of code. Instead of going line by line through these large chunks of code, you can go precisely to the point where you think something wrong is happening, and then you can go about debugging a little bit before and a little bit after. What we do next is something that we're going to... All right. So we have seen in the previous chapter that messages are a good starting point to do debugging. So we have hit this message here at runtime. SAP has stopped at this breakpoint. Now what? So it's like this. So this cost center report contains a bunch of blocks of code, and each block again could contain a bunch of blocks. And we have identified breakpoints somewhere here and here, say. And the SAP has come all the way and stopped its execution here. And then it's throwing that message. The message is not what we want to debug. It's what happens before that message that has led to this message being thrown. That's what we want to find out. This situation that has resulted in that message being thrown could potentially have happened anywhere before this line. But more often than not, it happens just before. 1 line, 2 lines, 3 lines, not more than that, most of the time. So let's find out what has happened that has resulted in this message being thrown. So we know the yellow arrow represents the exact line in the program where SAP has currently stopped. And the previous line here states that if select is initial, then throw this message and stop the program. Well, it has stopped the program, but we want to find out what has resulted in it. So the statement over here, if select underscore costel is an internal table, which is similar to a structure. So it's a grid of data that's populated at runtime. And this statement says, if this structure or internal table is initial meaning that there is no data in it. So if there is no data in this structure or internal table, throw this message. Well, for some reason, this internal table was not filled up. So it is initial, which means it's blank, and so that message was thrown. Fair enough. Now let's find out where exactly the structure is being filled. So we got to move up in the program, not move down. So programs typically flow down, top to bottom, or in loops. But in this case, we want to go up one statement and find out what has happened. How do you do that? So we know what this if statement does, but we want to go one step up right here and start debugging from there. How do you do that? So place your cursor on the statement where you want the execution to go to debugger and click on go to statement. You see the arrow has moved up and placed its focus right on the statement where we want it to stop. Now perform blah blah blah. We don't care what this is, but the statement says perform something. Perform something means execute a block of code. Get CC and post date, it is called a function or a routine, and perform executes that function or routine. So what is a function or routine? It's a block of code. So perform get CC and post date is asking SAP to execute a chunk of code that's there in this routine or function. And then if you hit F6, it executes that routine and comes back to the if statement. Well, what does that tell us? Nothing, right? So it executes something and then comes to the if statement. But we want to find out what exactly is happening in that chunk of code. So again, place your cursor there, click on go to statement, and then instead of clicking the second button, F6, click the first button. I call it step into. So if there is a block of code, SAP executes it and then goes to the next line. But if you want to go into that block and go step by step, you can click on the step into button. So click on the step into, and it's going into that little chunk of code. And then what does it do? Now you can go step by step, F6, and then there is a select statement. What's a select statement? A select statement is how data is fetched from the database table. So a select statement essentially comprises of 3 blocks. Select what and from which tables. It could be one or more than one table. And the third part being where it is being pulled from. So this contains the conditions based on which the data is being pulled. Example, select sales orders from VBAK table where date less than today, right? So it fetches all the data from VBAK tables where the date is less than today. Now you might not need every bit of field from that table, but instead you can select what, meaning select sales order and sales order creation date from sales order table VBAK where order date less than today. This is typically the format of a select. Now it could be more than one table, but we are not here to understand how select statement works. But just understand that a select statement has 3 sections. What? The tables from where it's selected, and the conditions that are specified in the where clause. Well, in this case, this program is selecting all these different fields, which is the what of what that select is doing, and from which tables. From PPHD. And what are the conditions? And here are the conditions where this is equal to company code, this is equal to PP, so on and so forth. Now, don't be overwhelmed with your select statement. The purpose is not to understand the entire select statement, but to see in general if it is picking data from the right tables and if it is fetching the right data. In our case, it's fetching the data from PPDHD table. Well, if you are from a finance background or costing background or HR background, you might understand it. But I don't care. I don't understand what the table is. But if you are from that background, you would understand what the table is. And then if it is fetching the right data meaning the where condition and the list of fields. Well, let's go to SE16 and find out if we should get any data for the selects that we have done. So go to SE16 and type in ppdhd, the table that select statement uses. And for company code, type in 9999. Does it have any data? Oops, it does not have any data. Well, we know because we have put in a dummy code, but you get the idea, right? So whatever company code you're using, you can go there, put in on your selection criteria and see if you should get data. And if you get data here and not in this select statement, then maybe you need further refinement. Go filter by all the selection criteria, company code, maybe there's a join with another table. You have to go find out what data is in that table and all that complicated logic. And this is very case specific. If I'm an SD consultant and I'm looking at sales data, so typically my sales order header table is VBAK, item table is VBAP, schedule line table is VBEP, and status table is VBUK, and so on and so forth. Now, if I'm looking at a select that's pulling data for sales order header, this is the table that it should be pulling from. I would know that as a functional consultant. So whatever the report is doing, I can cross-verify it here. Sometimes it's not just one table, because if you want to look at the entire sales order, you should be looking at these three tables together. Sure, I'll just go to an SE16 across all these tables one by one and see if I got the right data or not. So in our case, the select statement is right because there's no data for that company code. So the program is doing its job well. So that's how you use messages to quickly go and dive into these blocks of code and figure out where exactly things are going wrong. And then you can go one step up or one step down using the go to statement or execute, and then go step by step or go step into or step out of the program to find out what really is happening behind the scenes. So let's summarize what we have learned here. So we know what messages are, and we know how to view the definition of a message. And from there, we know how to use the where used to identify what are the places in the program where this message is being thrown. And then we also seen how to use the go to statement to go up and down in the program to quickly understand where potentially things might have gone wrong. Number 5, we also have seen what is a step into and step out. So step in is F5, a step out is F7, and of course F6 is how you execute line by line. And then we have seen a select statement. We have seen the structure of a select statement, and we have seen some examples of how we can cross-verify that with SE16. Well, that concludes this chapter. So see you in the next chapter. In the previous chapters, we have seen 2 ways to identify the starting point for debugging. The first way is that you should know the user exit or the body or whatever, and then put a breakpoint there and start debugging. And SAP will start right at the point where you have set the breakpoint, and then you can debug from that point onwards, either before or after. So the first one is you know the user exit or body. The second way is to identify a particular message in the code and then put a breakpoint on that message and start the debugging. So the second way is you go by the message. So 2 ways you can dive into the code. And at runtime, we have seen examples of how we can view the data in structures, variables, so on and so forth. If you remember the golf example, Viewing data, either in structures or in variables, is more or less like viewing the different parameters of your goal swing at any given point in the swing. Let me show you. So this is me. I start the golf swing here, and then I'm supposed to hit, say, 100 miles per hour here. I can freeze the frame here and identify the different values. Say speed, 60 miles per hour, angle, say 30 degrees. Once the swing starts here, there's nothing we can do, right? All you can do is just view the parameters at different points in time. This is definitely useful, no doubt about it. Freezing the frame or putting a breakpoint and identifying what the different values are is the fundamental aspect of debugging. It's the most useful aspect of debugging. But let's go one step further. Imagine this scenario. If I want to hit it at 100 miles per hour and my speed here is 60, say I'm not reaching 100 here. Now what do I do? We could do a little simulation. Say we change the value of this variable temporarily to 70, meaning what would happen if the speed over here is 70 instead of 60? Can we simulate that? Wouldn't that be nice if I can do that? That means if I can achieve this speed, then probably I can achieve my desired target. So the ability to change the values at runtime and see how the system reacts is called debug replace. Let's see an example. Let's go to the same old example. You find out that there is a sales order and we are trying to issue an output. The output should print a PDF, but it's not doing it. So you want to debug. What do? You go to the output routine, which is a piece of code. Put a breakpoint here, execute the program, and SAP comes and stops here and waits for you to proceed further. Step by step, step in, step out, execute. What can you do now? Say at this breakpoint, we have realized that something is missing. Say the incompletion log, or there is a delivery block, or whatever. There is an issue, and that's what we have found out when we have put a breakpoint here. We have two options here. Option number one is to go fix the issue. The issue could be incompletion. The issue could be a delivery block. The issue could be anything that stops the output from being issued. The second option is we could simulate. We could fool the system. We could trick the system into saying, hey, you know what? This is all good. Go ahead, go further. Example, the document is incomplete, and that's what we have found out using our debugging. And how did we find that out? We said COM-KB1 UVAll equal to A. A means it's not complete. C means it's complete. Because it's A, the system says exit. And that's how the code has been written. And instead of going back and fixing the completeness of that document or whatever, we could temporarily make this to C and say, hey, you know what? The document is complete. Go ahead, issue the output. This is what I meant by tricking the system or fooling the system into believing that something that is not true is true. So let's see that in action. So go to SPRO. So we have put a breakpoint here. And let's go create another sales order. And save it. Let's go check what is the value of this UV all field. Double click and the value is A. And if the value is not equal to C, the system is going to exit. But what do we want to do? We want to trick the program. We want to change this value temporarily and say, hey, you know what? Everything is good. Don't quit the program. And in order for us to do that, we have to change the value to C. How do you do that? Very simple. Click on the pencil button. Change the value to C and hit enter. Now, watch what happens. The arrow is right here. And now we're going to go one step further. And if com kbc1 is not equal to C, it's going to exit. But we've made it C. So it's not going to exit, right? So we tricked the system by changing a value into saying the document is complete. Don't worry, go issue an output. Let's see if it really issues an output. We're not going to debug any further. We're just going to say execute, 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 and then say save. Now, ideally, it would not have issued an output. But let's see if it did issue an output. So go to sales document, display, and sales document issue output to, and there you see your output. So this is how you use debug replace to temporarily trick the system or temporarily simulate a scenario to achieve what you want. Now, most of you might have a question here. When I can go complete a document in VA02, what is the advantage of doing debug replace? This is just an alternate way to do things? Very good question. Let me give you an example where debug replace is going to be extremely useful. Logic that happens in external systems is not under your control, right? What example? Say there is an order that's created in SAP. Sales order, purchase order, transfer order, doesn't matter. SAP calls an external system for a particular logic. It could be anything. We're going to see some examples. And during the process of creating a sales order, if this returns something, it's going to do something else. And if it does not return it, it's going to do something else. If it returns a true, it's going to proceed further. If not, it's going to do something else. If you want to know some examples, tax calculation in the US is a very good example of this. Say there is an SAP system and tax in the US is based on what is called as a jurisdiction code. Well, SD, MM or FI consultants would have a very good idea of what this is. But for the rest of us, let's just say that tax is calculated outside of SAP. It could be Vertex, Taxware or any system. And then it returns a percentage saying the customer is taxable and it's taxable at 8%. Another simple example is you want to ship some goods to a customer, and how do you get the freight? You have a connection with a FedEx system or UPS system, and you give some parameters, say the state that it's going to ship to, the weight, volume, so on and so forth, and it's going to return a value, say $21 is the freight. I can go on and on and on, but I think you get the point. Wherever SAP executes a function that returns a certain value, and that function could call another external system, or it could be even internal. The point being, you don't have a lot of control over what is being returned. I take the examples of external systems. Why? Because you don't know what they return. It's a call that goes over the network and gets you some value. So, and if the code is written in such a way that if the customer is taxable equals true, then do this logic. Else, exit. Now, when you're testing some things, this system might not be under your control. So you want to simulate a scenario where this is true and then find out what's wrong in this piece of code. So this is the piece of code that you want to debug, and unless this if statement is met or it passes, the code will not come here. Now in situations like this, you can use debug replace. You can just make this true irrespective of what the external system returns. That way, you can easily debug programs under situations where the values of the variables are not under your control. All right, so that was debug replace. So let's summarize what we have learned in debug replace. Debug replace is a quick way to change the values of the variables at runtime so that you can control the way the program flows. What are some examples of debug replace? We have seen one example with outputs. Another example or a more useful scenario is when a function executes and returns a value. What the function does is not under your control. In cases like that, you can use debug replace to change the value of the variable to whatever you want. So that was debug replace. See you in the next chapter. Well, the next topic is watch point. We know what breakpoints are, but what are watch points? They sound similar, but they're not. To understand watch points, we have to understand the context in which they are used the most. They are called loops. What is a loop? So a loop is something that goes round and round, right? So in the context of ABAP, if a block of code is being executed again and again, 10 times, 5 times, 100 times, it's called as a loop. Let me give you an example. If we ask SAP to fetch all the list of cost centers that are associated with company code, say 1000, what does the system do? The system goes into a table and fetches the details. There are so many of them, right? And then maybe it does some filtering on it or some further action on it. The way it does that is with a loop. So it looks at the first record, see if everything is satisfactory, selects it or unselects it, and then moves on to the second record, and then moves on to the third record, and then moves on to the fourth record. And this process of going through n number of records is called as looping. It's a standard programming construct. Another example. Go through all the line items in a sales order. Say there are 100 line items in VBAP. That's the table. So there are 100 line items. And the program pulls them from the database and maybe processes them. A typical example of processing line items could be pricing. maybe discount calculations need to be done based off of a particular subtotal. In which case, it has to go through the subtotals of all the line items. So starting with line item 1, 2, 3, da da da, da all the way until 100. That's another example of a loop. Now, in cases like this, when you're trying to debug, and if you go step by step, it's going to take a lot of time. Let me tell you why. So this block of code right here is executed. Say, for example, you're calculating a subtotal. That's what this block of code is trying to do. And it's calculating the subtotal for every line item. So it loops through this block of code 100 times in case of this example. And if you want to look at the situation or subtotal of line number 53, you'd have to wait in line. Go step by step 52 times until you reach the 53rd line item. Well, that's a pain, right? You don't want to really go through the loop step by step because it's the same thing running again and again. You're not interested in the first iteration or the second iteration or the third iteration. You're only interested in the 53rd iteration, which represents the 53rd line item. So how do you directly jump to the 53rd line item? Very simple. You put a watch point. Put a watch point and say, tell me when the line number equals 53. And then don't go step by step. Instead, just click execute. So SAP will process all the line items. And when it comes to 53, it realizes that you have asked it to set a watch point. Oh, the user asks me to stop right here. So it automatically sets itself a breakpoint and stops right there. Stopping at the 53rd line item is just one example. You could watch for other variables. Stop when the discount is 10%. You don't know which line item has 10%. If you know the field where the discount is located in the table, you could just say, watch for a value of 10% in this variable. Let's see the example of the cost center and you'll understand how this is done. So we go to the Z cost transaction, which is our cost center example. And if you execute it, it just goes and fetches you all the values, right? What we are interested in is to see some examples of loops and then set watch points. So go to SC38. And this is our cost center program. We know that because we have seen it previously. And in this program, let's look for some examples of loops. There are different ways in which loops can be done in SAP. We're just going to look for some simple examples. Go to find and then search for loop. Okay, so here are some examples of loops. So let's just double click on one example. So what does this line say? Loop at this table, loop at this table, and then it does something else here. It searches for some parameters, so on and so forth. Now we can put a breakpoint here, like so, and then open another window and try and execute the cost center transaction. Now, with any luck, we might hit a breakpoint. Now, we have hit a breakpoint. And let's see how we go through this loop step by step. So the way we go step by step is by clicking on this F5 button or the first button in the toolbar here. So we could do step, and then it's looping at this table. And you go inside, read some data, and then this is the block of logic I was talking about. It could be, reading some lines, writing some data, checking for some values. We don't care. So it does that step by step. and then does something. And end loop is where the block of code in that loop ends. And as soon as it hits end loop, it moves to the very beginning of the loop statement. Let's see that. See, it comes back to the loop again. So it loops on and on and on until there is no data. Or we could break it in between, but we don't care. It loops on and on and on until there's no more data in this table to process. So what does this table have basically? So if you look at this table, so it has so much of data, so many rows of data, and it's looping through all these lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has 12 lines. So 12 lines is a very small number in SAP. Sometimes you could even be looping through thousands of lines. And in cases like this field right here is a good friend. Tabix. The field tabix refers to the line item that is being currently processed. If the loop is looking at line number 9, the tabix value is going to be 9. If it's looking at 1, it's going to be 1. Currently we are looking at 1. So let's continue further and see what the value of this is going to be. So I'm going to say F5, and you see the value change here? What it means is now we are looking at the second line item in that structure or table. And it goes on all the way until 12. And like I said, 12 is a small number. What if the value is 120 or 350? It's very tiresome to click on this button, right? Again and again and again and again and again for 120 times or whatever. Instead, what you can do is set a watch point. So how do you create a watch point? Click on watch point and then enter the variable that you want to watch. What is the variable that we want to watch? Psi-tabix. So enter psi-tabix and click on this additional condition and then say psi-tabix equals 7. Click OK. Now we have created a watch point, and let's see how the system reacts when we click execute. Now remember, the current line item in that table is 1. So the system is going to the first line in that table. We want the system to stop at the 7th line, and the way we're going to do that is just click execute. And look at this. The system has skipped through line 2, 3, 4, 5, 6 and stopped at line number 7. So this is a very simple example of how you use watch points. Another example of a watch point is looking for any kind of changes. For example, in ABAP, when going through a loop, you want to figure out where exactly in this loop a value of a particular variable is being changed. In that case, you don't need to specify the equal to or whatever. You can just say watch point, and anytime the value of that variable changes in that loop, SAP will hit a breakpoint. So once again, you have 100 line items, and you believe somewhere in one of these lines, the value of a variable, say price, is being changed. You don't know where. So you could just say, put a watch point on price, and then execute the loop. The system will watch out for this variable price, and when it changes, maybe say 53rd line item, it will stop right there and tell you that this variable has changed and will put a breakpoint. So this is another example of how you use breakpoints. There are more examples of how you can use breakpoints, but these two examples are more than enough to understand and use breakpoints. So the first example was to set a breakpoint for a particular value. The counter is 7 or price equals $20. The second example is watch for this variable and tell me whenever the value changes. So you're not saying the variable should have a particular value, say $20 or psi-tabix is 7. You're just saying that tell me whenever this value changes. So in the loop, whenever the value changes, it'll let you know and stop the program right there. And now it's time to conclude what we have learned in this course. It's a fast-paced course, but we have learned a lot of things. We started all the way with understanding why debug programs. So we started out with the why, and what we have realized is debugging is an essential skill for any functional consultant. So the reason why we do debugging is because as a functional consultant, your configuration will only take you so far. Beyond that, there is a lot of customization. And when you customize, you do that using ABAP. Of course, your technical consultant does that for you, but nevertheless, it's being done. And when you're trying to solve problems, anything that goes beyond configuration, which is what happens 90% of the time, you're basically at the mercy of the ABAP consultant. Which is good, which is okay. But you don't have to depend on them every time. Because sometimes it's like testing for landmines. If we can quickly do a little bit of debugging and identify the broad areas where things could have gone wrong, you could then direct your ABAP consultant to probe further. The second reason is, even though an ABAP consultant can identify problems because he knows the code, he might not know each functional area. For example, SD has different set of tables, different set of logic. MM has different set of tables and a different set of logic. Same thing with CRM, FI, CO. Since you know the area that you're working on, it's easy for you to identify the tables, the programming logic, the messages, user exits, so on and so forth. So as a functional consultant, your knowledge of the system, your knowledge of what's going on in terms of functionality is going to be extremely useful to quickly identify and debug problems much better than an ABAP consultant. And then we moved on to understand how to do debugging. Basically, we have understood that there are two ways to do debugging. The first method is to do debugging via system messages. The system throws an error or a warning. You figure out where exactly it's throwing that error. Just go a little bit above and then you'll find out probably some of the reasons why that error is happening. The first method is via messages. It could be warnings, errors, or informational messages. The second method is by knowing which user exit might potentially be the source of a problem. So a good understanding of which user exit to put a breakpoint on, or a body or a BTE, would be extremely useful in most of the cases. And of course, we know how to put a breakpoint. Just select that line and then hit the breakpoint button and you're done. And we have seen some of the intricacies of how to do debugging, like step in, step out, execute, which are the different ways in which you execute a program. Is it line by line, or is it one block at a time, or you want to execute until you hit a breakpoint, so on and so forth. And then we have understood some things about programming and structures. What is a structure? A structure is like a table, and they're used a lot in ABAP. And we know how to view the data in a structure, how to analyze the data in a structure. And we have also seen some examples of internal tables. And finally, we have also seen watch points. A watch point is like a trigger. You don't want to go through the entire loop to figure out what's really happening, maybe at line number 53. So if there are 100 rows in an internal table that you're iterating, and you want to find out what's happening at line number 53, you set a watch point for line number 53, you set a watch point for line number 53, and the system stops right at line number 53, skipping through all the rest of the lines. It's just a quick helper for you to debug programs. That's it for debugging for function. That's it for debugging as a function consultant. I would definitely love your feedback. If you need to see something else in the program, please let me know. Send me a message and I'll try and add to this course.